However, in order to satisfy the requirements of the Poor-Bay diagram, we have to put a current through the system. We have to control the current that goes through the system and measure it. That's this. So in other words, we have to put a charge through the system. The voltage comes up here through the voltmeter, up through here through the ammeter and down into the reference electrode, which is this half of the cell. The other half of the cell is the half cell, which we have already used and shown here. This is the reference cell, and we have to pass a variable current through this cell so that we can plot the graph which is known as the Poor-Bay diagram. This is the variable input, variable charges. Okay, there's a total of 9 volts here, and I'm putting at the moment 5 microamps through. As I increase this, you will see that there's 9 microamps, and that's to be plotted against the reading on this meter, which is 0.773 millivolts. This has gone negative, and that has gone negative. So as we adjust this, we can actually plot the Poor-Bay diagram. You will notice that the baseline of the Poor-Bay diagram is the pH. That is the pH which we can measure of the electrolyte, which is here, which is in contact with the metal, which is the working electrode in this diagram, which is DIN 50918. Now this is the scientific requirements to actually make measurements of the corrosion reaction of steel or copper or whatever, aluminium, whatever you want to measure the corrosion reaction of. This is the way you have to do it. You cannot take that, stick it in the ground and connect the other side to the pipeline and expect that to be a scientific result rendering data that can be sensibly analysed. It cannot be.